Today we're going to start discovering some of the key features of functions. Particularly, we're looking at the relationship between x's and y's, so the inputs and outputs of a function. Before we get started, let's talk about what an actual function is. So it's a type of relationship And so what that means when I say it's a type of relationship, well, in math we use type of relation. So we're talking about a relationship between x's and y's. Specifically, it means that for every x value, there can only be one unique y value. So that just means that in a graph, you would never see the coordinates 2, 1, as well as 2, -1. That's the same x value, but two different y values. Therefore, it's not a function. The domain is a set of all possible inputs. Inputs are also known as our x values in a relation. The range is a set of possible outputs in the relation. So specifically the y values. Interval notation is a pair of numbers that represent the boundaries of an interval. So let's say we have a number line. And we want to talk about all of the numbers between -1 and 2. Now notice that I have an open circle at -1 and a closed circle at -2. An open circle means that we are not including that point. So think of it as using either a greater than or a less than symbol anytime you see an open circle. Then if it's closed, we want to include that point. So that's equivalent to either a greater than or equal to or a less than or equal to. So if I want to write this line in interval notation, I have a pair of numbers that represents the boundaries. So the boundaries would go from -1 to 2, and we put a comma between those two numbers, and then we want to identify if we're including the -1 or not. Because it's an open circle, we're going to use around parentheses. Around parentheses means not including, and then on the 2, we're going to have a square bracket, and that symbolizes including. So let me write a little note over on the side for you. The next vocab word, zeros of functions, that's just a fancy way of saying x-intercept. Now let's look at an example. What is the domain and range of y equals x squared minus 3? So the first thing we need to do is graph it. A friendly reminder of how to graph. We're going to make a table of values. We're going to pick a generic set of x values that are centered around the origin. And then we take each number and we plug it into our equation. One thing to remember is that when you are using the x values that are negative and you square them, that's going to become positive. So -2 squared becomes +4 minus 3 is equal to 1. Then we're going to graph. So even though our table of values stops at -2, and we're not doing numbers less than -2, our graph is actually continuing. So when we identify domain and range, domain are the x values and range are the y values. So we're really answering the question, where does this graph exist for x values and y values? So for x values, we're looking left to right. Now this graph goes on forever and ever. So that means that if I choose an x value that's really, really small, it does have a y value. It's just way up here. So high, it's off my graph. But it does actually have a point. We can't actually graph every single point, or else we'd be graphing forever and ever and ever. So the arrows means that it continues going up, and as it goes up, it's also going to the left. So the smallest number in our domain is actually negative infinity. It's not a specific number. And because it's not a specific number, we need to have a round parentheses. So round always with infinity. And on the right hand side, the graph is going to continue going up. And as it goes up, it goes to the right. So we're going all the way to positive infinity. Another way of saying this is all real numbers, but this is interval notation. Now let's look at the range. Now range talks about our y values. So our smallest y value is right here at -3. And then the y values get larger and larger and larger. So the smallest y value is -3, and it's that point right at the vertex. The graph is going through that point, so it is included, and therefore a square bracket. Because the graph goes up and up and up and up, goes to infinity, infinity always has a round parentheses. The next concept we're going to talk about is positive and negative intervals. So we want to look at a graph and say, where is this graph positive and where is this graph negative? But we first have to understand what that means. Positive intervals are the set of x values for which the graph is located above the x-axis. Negative intervals is a set of x values where it's located below. Now the point that splits between above and below the x-axis are the x-intercepts. So that means that we need to be able to find our x-intercepts. For what intervals is f of x is equal to x squared minus 9 positive? Hint, your answers will always be in x values. So here's my graph. Anything above the x-axis is positive. Anything below is negative, based on the definition up above. I want to write what the intervals are, and my answers have to be an x value. So I'm going to highlight it so we can have a visual. This is the part of the graph that's positive. This is the part of the graph that's negative. And on the actual axis, it's neither positive or negative. And I'm going to put a star because I'm telling you this is a little concept that a lot of people forget. So let's look at the first interval. So the leftmost side of this interval in green, interval number 1, is negative infinity because it continues to go up and to the left. And then the interval stops at the x-intercept, which is -3. Infinity, always round. Now the -3 is on the x-axis, and on the x-axis, by definition, we're neither positive nor negative, so we don't want to include it. So it's also going to be round. Now we actually have two intervals that are above the x-axis. So the second one starts at 3, but we don't include 3, and it goes to positive infinity. Now the negative interval is everything between -3 and +3. So the entire graph between -3 and +3 is negative. We use round parentheses because the graph is changing from positive to negative at the x-intercept, and at the x-intercept it is neither positive or negative. The last thing I just want to review is x and y intercepts. So x and y intercepts are found on the axis. So for the above example, our x-intercepts are -3, 0, and +3, 0. And our y-intercept is 0, -9.